Alright, what is up, everyone? Back on day 23. We did just actually finish day 22 a few minutes ago. I didn't really have time to do it earlier, but no worries. It was about map folding. Unfortunately, yesterday I just didn't read in the full input, and so that's what ended up being the issue. And then the second part is instead of continuing straight off the side, you kind of like fold the whole thing into this cube. So I legit printed it out. Here's mine. Gotta fold them up and figure out how to go off of it. So that was that. Not great. But we are off on to day 23. Let's do it. You enter a large crater of gray dirt where the grove... Ooh, that is loud. Sorry about that. You enter a large crater of gray dirt where the grove is supposed to be. All around you, the plants you imagine were expected to be full of fruit instead are withered and broken. A large group of elves has formed in the middle of the grove. But this volcano has been dormant for months. Without ash, the fruit can't grow. You look around and see a massive snow-capped mountain towering above you. It's not like there are other active volcanoes around here. We've looked everywhere. But our scanners show active magma flows. Clearly, it's going somewhere. You finally notice at the edge of the grove, you pack almost overflowing from the random star fruit you've been collecting. Behind you, elephants and monkeys explore the grove, looking concerned. Then, the elves recognize the ash cloud, slowly spreading above your recent detour. Did you just... Before any of them can form a complete question, another elf speaks up. Okay, new plan. We have almost enough fruit already, and ash from the plume should spread here eventually. If we quickly plant new seedlings now, we can still make it to the extraction point. Spread out. The elves reach into their pack and pull out a tiny plant. Plants rely on important nutrients from the ash, so they can't be planted too close together. There isn't enough time to let the elves figure out where to plant the seedlings themselves. You quickly scan the grove, your puzzle input, and note their positions. Come on, man. Like, we all know that under time pressure, that things do not go well, right? Alright, let's see. Scan shows pound elves and empty ground. Outside your scan, more empty ground exists a long way in every direction. The scan is oriented so that north is up. Orthogonal directions are written north, south, west, and east, while diagonal directions are written northeast, northwest, southwest, whatever. Okay. The elves follow a time-consuming process to figure out where they should each go. You can speed up this process considerably. The process consists of some number of rounds during which the elves alternate between considering where to move and actually moving. During the first, this feels like a graph traversal problem again. Do not like. During the first half of each round, each elf considers the 8 positions adjacent to them. If no other elves are in one of those 8 positions, the elf does not do anything. Oh, okay, game of life, got it. Otherwise, the elf looks in each of the 4 directions in the following order and proposes moving 1 step in the first valid direction. So if there is no elf in the north, northeast, or northwest position, the elf moves north 1 step. Okay, so if like there's no one in the top 3 above you, move north. Otherwise, check south, east, west, and then east. North, south, west, and then east. Okay. After each elf has a chance to propose move, the second half of the round can begin. Simultaneously, each elf moves to their proposed destination tile if they were the only elf to propose moving to that position. If 2 elves propose moving to the same position, none of the elves move. Finally, at the end of the round, the first direction the elves considered is moved to the end of the list of directions. For example, during the second round, the elves would try proposing a move the south first, then west, then east. Okay. Third, whatever. Smaller example, consider these 5 elves. Okay. I think okay. Elves like to check after round 10, making sure they get progress toward covering the ground. Okay. In this region, the number of ground tile. Okay, wait, what? Make sure they're on the right track. The elves like to check after round 10 that they're making good progress towards covering enough ground. To do this, count the number of empty ground tiles contained by the smallest rectangle. The edges of the rectangle should be aligned north. Okay, that's fine. Example above, that's this in the region. Simulate the elves process and find the smallest rectangle that contains elves after 10. How many ground tiles does a rectangle contain? Okay, cool. So let's do it. This actually seems, I mean, famous last words, seems not even that hard. So expanding grids are usually just better for sets. So what I'm going to do is val grid equals, we're just going to read in the lines, and we'll do, we're going to map, actually let's just read them in elf positions, I don't know. And then dot map indexed, and this is going to be a row, and then row dot map indexed column and value, and then we'll say if value equals one of these, then we're going to we can make a coordinate r, this should be c, I'll just say, actually this doesn't matter, we can just do return if value equals this. We actually don't need this return, else null actually. Oh, this is going to be RC. And then just format the whole file. There we go. And then filter is not equal to null. All right, this should give us a list of coordinates, I think. Yeah. How do I get this to be? Let's just return here. Let's just return dot rc in dot max value, and then I'll just filter on that. So not equal to this, and then that should give us a non-null elf position. Okay. This is going to be a long, and so okay, the first part is we are going to propose moving direction. So we'll do P10, and then we're just going to do val cur elf positions equals elf positions dot That's weird. That shouldn't be there. Two immutable lists, so we'll get a copy. Then we'll say val post positions equals, and then we're gonna go through each current elf position and we're gonna map it to. So what we want is we want to take the, we'll say what do I want to do? Okay, I want to generate suggestions, and this is going to take in C coordinate, and we're going to return a list of coordinates, right? And so this is going to return list of and then list of, and it's going to be C dot, how do we do this? C plus coordinate. So the first one is the north ones, right? So we're going to say -1, 1. Okay. 0 and 1. Okay, and then the second one, was it? It was north. Is it north, south, west, and east? North, south, west, east. So north. Okay, south is the same, but all these are minus, right? Okay, and then we're gonna do west. So this is south. West is going to be -1 for all of these. So this will be this. This is -1, 1. And then this is going to be east. And east is all of this except they're all +1. Okay, so let's just double check this. North all has +1s. South all has -1s here. West all has -1s for the X. East has +1 for the X. Okay, cool. So we're gonna say val suggestions equals generate suggestions for this one, and then we'll say we're gonna say val suggestion equals suggestions dot first or null of dot none where it in. Okay, so pick the first one where none of those currently have an elf, right? Let me just double check this. It says finally first direction, the elves consider is move to, sorry, after each elf has a chance to move. Yeah, so no other elves are in any of those. Oh, during the first half, each elf considers the 8 positions adjacent to them. If no other elves are in one of those 8 positions, the elf does not do anything. Okay, otherwise we propose move. Okay, okay. So, so I'm just gonna do kind of the lazy thing here, which is, if none of those are it in current elf positions. So then how do I want to do this actually? I guess I can just return null. Yeah, that's fine. Return @map null. Okay, otherwise what we're gonna do is we're gonna go through here and we're gonna say find the first one where we don't have any. Okay, look at each of these. And propose move. Okay. Propose is moving one step east. Cool. And each of those are the middle one here. So this is north, south, east, and west. So we can take those as well. So this should be a list of coordinates. Yeah. And then we'll say suggestion 1. Does that work? If suggestion not equal to null, suggestion 1 else null. Is that fine? All right, cool. And then we can just filter these for it is not equal to null. Okay, so then we want to do, we need to pick which elf is going to go there. We probably do need to do that. We probably actually need to return this as like, this filter probably doesn't work. Probably, you do a pair of 2 null. I guess we can just move, propose a move to the spot that we're in, right? So it to it, and then it to it to it. Okay. This is a pair from a place to a place. Yeah. Cool. And then it says finally at the end of the first round, if the elves considered is moved to the end of the list direction. Okay, so this to do rotate based on round number. So I'll just say round num, and then we'll say val round cycle equals. Actually, is there just a suggestions dot? No, there's not a rotate. Okay, that's fine. We do want to rotate this though, so I'm gonna say val rotated suggestions equals, and then we're gonna do round number mod suggestion size. We're gonna take these off, right? So we're gonna do this dot dot remove. What the heck? Oh, it's because there we go. Remove. I think give utility for this. Hold on a sec. Remove last in. I do, but I don't have that for the beginning. Oh man. Okay, what about take? Take suggestions dot. It's not that. It's round num mod suggestions dot size. Okay, and then we'll just do we'll do repeat same number. Actually, we can just do this dot size. We're gonna remove the element remove at 0. Okay, and then we're gonna do suggestions dot add. This is kind of jank, but oh well. All right, that gets us what we want. So each round we'll kind of look at a different proposed spot. Okay, so this gives us the right proposed locations. And then what we want to do is we want to map these so that the position is a key in a map. So proposed positions dot associate. Actually, we're gonna do group by and group by it dot second. Pose position to pairs. That's fine. And then what we're going to do is we're going to say we can move as long as it's finally at the end. Second half, simultaneously each moves to their proposed destination tile if they were the only male elves to propose there. If 2 or more elves propose moving in the same position, none of those elves move. Okay, so we don't really care that, like, we mapped no move to like moving to the same spot that we're at, and that's fine because nobody would try to move there, so we actually don't need to do any special handling here. So we can just say that means that every elf is going to have a spot that they end up. So this is actually sweet, because what we can do is we can say val new positions equals mutable list of coordinates. And then what we're going to do is we're going to go through each key in actually, we'll just do each element, right? This is going to give us each entry. That is in, no, this is what I want. Right, so is this a map element now? Cool. Okay, so we can say if e dot value dot size is 1. So if there's only one thing trying to move to the spot, then we'll grant that move, right? So propose positions, actually, sorry, new positions, add e dot key, that one moved. I hope we don't need to be tracking like which one's which. That'd be not, like, it's not really something we can do right now. So otherwise we're going to add all, and we're just gonna let them stay where they are. So the one where they are is the first element. Okay, so we're gonna do e dot value map it dot first stay still move. Okay, so this seems good. We're not gonna be able to print anything, but let's return rectangle size. Okay, so this is new positions. The last thing we have to do is we're going to say kernel positions dot clear and then kernel positions dot add all new. We could have just reassigned it. I don't know. I don't care. Did that. Okay. So now we need to find the bounds of the box. So we'll say val minx equals kernel positions dot min of it dot x, and max is max of x, and we'll do min y. Don't hit insert, and we can switch these to y, and then this will be max x minus min x times, is this the issue? Min max y minus min y dot to long, and then we also have to subtract out the number of elves there are, so minus current elf positions dot size. Okay, and we're hoping that this is equal to 110. So if it is, then we will submit the answer. Oh, I just hit day 22. It's the old day. Have I really not run today? Oh. Cancel. Don't do that. I think this is the start. I to 110 but got a 99. Okay. So let's do print elves, and we're gonna do current elf positions. Wait, maybe I'm not supposed to in this region. Okay, I probably am, so. Okay, and then we pick north first, so I think what I actually want to do is I want to try to print it in the way that it's like laid out. So we'll say for y and max y down to min y. Okay, and then for x in min x x, let's do var s equals this, and then we say if man. Okay, this is gonna be a slow thing, but contain. Let's just do this actually. Set equals this dot to set. And say this. Chord dot xy in set else, so s plus equals this. Okay. Okay, it's to round. Okay, that. I'm actually somewhat confused. It doesn't really seem like they're splitting out that much, so... Oh wait, is this what I put in for the initial state? I don't think it is. I think I put in something else. Yeah. Okay, it feels important to start with the right initial state. Yeah, still didn't get the right answer, so that's good. This doesn't look at all the same. Oh god. Okay, let's make sure that I'm even parsing it correctly. Seem right. Okay. Print elves, current elves. Initial position, and we're just gonna print an extra that just to get that. This is annoying. I'm sure that I just have like one and a minor. Okay, this is totally backwards. This is my problem. Maybe it's not a problem. No, it kind of is. So I'm mapping it index. I guess it doesn't matter if I have positive, like the actual numbers don't really matter. So what I can do is I can just treat the row as negative, right? So when I create this, I just say the row is going down, then this should... I mean, it didn't fix anything except for print stuff in the right, or in the same order, right? So this at least looks the same. Okay. And then this 3, 2, 2 looks the same. Okay. Round 2. Something's up right here. Oh wait, never mind. Never mind. This is these are off by 1. Right. Just let me just fix that. Because round is 0 indexed. Okay. You know what the issue is actually? I need to do a +1 here. Forget this. I need to do a +1 because these ends are inclusive. So this is gotta be the right thing. Because you're supposed to include the actual outside of your squares, right? Yeah. Okay. Stop telling me that's wrong. Okay, that was stupid. I should have just input the number, no? Okay. Cool. This has got to be right. Nice. Under 1,000 too. Could have scored higher. Ah, okay, let's go. Seems you're right on the right track. Finish simulating the process and figure out where the elves need to go. How many rounds did you save them? In the example above, the first round where no elf moves is round 20. Figure out where the elves need to go. What is the number of the first thing where no one moves? Oh, okay. So, okay, I'm just gonna copy all this, and we need to get rid of the prints, right? So, long, get rid of this. Okay, these. So the first round where no, okay, so this is gonna be while true, and then we need var round num equals 1, and then we do plus. We don't need any of this. We literally just want to turn round num, and then what we're going to do is we are going to okay, propose positions. Okay, so we're going to say if proposed pairs dot all, and then we're going to say it dot value dot size is 1, and it dot, and then we also want to only do it when nobody moves, right? So it dot value dot size is 1, and it dot, let's get that value dot first equals second. Okay, and then this is supposed to be 20, right? Ditch these. Oh, what the heck? No, that was stupid. What did I do? Break. Okay, here we go. Oh, stupid again. Dude. Come on. You need to update these still. I'm just like spinning my wheels on that same thing. It was 19. Okay, that's fine. Wait, round num is... What's the question? Okay, I don't know. Let's just plus 1, dude. Let's just add 1. I don't know. We can debug later, but they all have size. Come on. Is there something I need to be doing to make this run faster? Here, this is what I'm gonna do actually. I'm gonna do our moving count equals 0. And then this will just be moving count plus. right? And then I can say if moving count equals 0, return. Is it +1? It's fine. This doesn't mean anything. Wow, this really frickin' takes a long time. Oh, no. So this is actually, this should actually be if e dot key is not equal to e dot value first. Okay, and then let's print this too. Print line round I'll say moving count moving. Okay. Yeah. How many? I don't even realize that there's that frickin'. Let's go look at the input. Oh man, this is gonna take a while. Is there any smart way to do this? I feel like there's gotta be, but just go look at this and see which parts that we're doing that are like stupid. Camera's coming down a little bit. Shall I keep going? There's probably some place. Oh yeah, like these checks. I'll run it after this, but the number is coming down already. This should have just been a freaking set, dude. This is stupid. This is dumb. But it's almost done. So, because making the current elf positions a set makes these checks like, you know, instant time, as opposed to this is having to iterate through the full lists. And since we don't need like ordered iteration here, yeah, this makes no sense whatsoever, but that's okay. We'll have the number here, 990. Probably drop some positions here, but what? That's curious. Maybe this +1 just straight up is not correct. So let's get rid of that, right? And then let's see if we can do a little bit of debugging. So let's do the first thing where this should just be to set, and then we can go through and map it. All this goes fast. And we're just gonna do var and then this is new position. Okay. So why the heck does he get 19? That's bad, right? Like let's print else. This doesn't matter. This can just be collection. This is not the right order. Huh. Okay. So we probably just didn't even get this right? So round 10. Let's go back. It's kind of weird though, right? That we got like the... Did we do these right? North, south, west, east. So north, south, east. East is this way, west. That's right. They describe these. Yeah. Okay. Some rounds in the first half. All right, so let's just go back to this, to the first half. That's so weird, right? And we're gonna apply our optimizations just real quick. Set val, and then this is just going to be equals positions dot to set, and cool. Let's run this, and then I think what we need to do actually is, oh, we have it printed out here. This seems the same now. Yeah, I mean, it seems because this is the bounding one, right? This is like, this is identical, right? So let's see if maybe there's something here that I didn't get. Maybe you're on the right track to finish simulate. Maybe I'm just not counting correctly. Like initial state, round 1, 2, 3, 4. Huh. I mean, this says round 10. It's like after round 10. I think it says, what is the first round? First round where no elf moved. What is the first round where no elf moves? Okay. I mean, I don't know. It seems like I have everything right here. I think I like changed anything. All this is still the same. This is all still the same. Oh, this is wrong. This is wrong though. Oh, okay. Shoot. Shoot, no. Oh, what a disaster. Okay. Okay, there we go. Because I was rotating a mount the wrong amount, so I was checking the wrong direction. Oh, that sucks. Okay. Let's see, do we get 20 now? No, we do get 19, but we should be doing +1 because we start at... Okay, this is good now. Okay, let's see. Round 20. Oh yeah, that's good now. Okay. Oh man, oh that sucks. Okay, I for sure, I think there's probably people who did not screw this up like I did, but okay, we should be through this a lot faster now that I made those optimizations. Oh, there we go. Oh man, off by 2 days, what the heck? All right, that's still good. Under an hour when we kind of struggled the other time. So yeah, we dropped a bit there because of just some kind of fuzziness. So I didn't quite realize that, you know, setting round number to 1 here changed what directional order we compare these in. But other than that, this was pretty good. So nothing really fancy here. You just simulate elves moving, you know? The basic algorithm we did was you take everywhere where they are. We generated the suggestions in the like north, south, west, east ordering. And then we rotate them. There's gotta be a better way to do this in Kotlin. Let me see. Kotlin rotate list, maybe? Oh man. Okay, rotate array in Kotlin. You can use collections.rotate. Let's try that. Collections.rotate. Oh, that's not what I wanted. Alright, so let's take this. And then let's just do collections.rotate. And we want to rotate this by round num mod. Actually, it doesn't even matter. We don't need to. It'll do the mod for us, I'm pretty sure. Okay, this is collections.java. Does it know? Alright, this should work actually. Let's run it, just double check. What do we get? It's 988. Oops. Does it rotate the wrong way? says rotates elements in the specified list by the specified distance after calling the method. The element at index I will be the element previously at I minus distance mod size. The element at 2 will be like I 2 minus 1. So it rotates it the wrong way. Oh man. I guess you can just rotate it by the negative round number. Let's try that. So I'll have to remember this one next time. This is kind of cool. Yeah. Okay, cool. Well, not bad. Like I said, we got under 1,000 and then 1228. Not gonna complain for having been stuck on some other days for a while. So that's it for today, day 23. We just got 2 days left, usually a day and a half. And like I said, we got the other, we did get yesterday just under the 24-hour kind of thing. Yeah, have real life obligations, so, but we rarely get in. So catch you tomorrow, day 24. Take it easy. Have a good one.